Okay, so in this video, I'll demonstrate a low velocity impact on the sandwich honeycomb structure using the Abaqus software. So coming to the first part, three parts were developed. First one was the bullet of the appropriate dimensions. Second was the circular honeycomb, like these. All were developed using the deformable sheet, and the third part was the plate that has to be attached to the front and rear end of the honeycomb. Now coming to the properties. In the property section, first of all we have to assign like develop a reference point at the top of the bullet. So we'll go to the tools, reference point, and we have to select where we want a reference point, so we just have to select. And further we have to assign the inertia and the define the mass of the bullet. So we'll go to create, point mass and inertia, continue, select the points to assign point mass. So we'll select the reference point, this one, and then done. We'll enter the mass, like I have already defined, so I'm not doing it again. So you can define like 1 or 1 kg or around your simulation needs. After that, like the bullet is complete, we have to assign the properties to the honeycomb structure and as well as the plate. So we have to define a material. So we'll go to create and we'll write the name which we want, new material, and in the general we'll get the density. Mechanical we'll do the elastic, and like I'll just show you what I have considered. I have taken the aluminium material and I've taken the values from the literature. So this was the mass density from here, and the elastic was this one, Young modulus, and this from for the plastic values we have to go to here. So I have considered the Johnson-Cook hardening model. So mention the values for the same, and for the Johnson-Cook damage we also have to define. So we'll consider the Johnson-Cook damage and input the all the variables. Then we'll go to damage evolution and displacement at failure. This value was also given in the literature. Similar, if you want to define any other material or assign according to your needs, you can like take the values based on the literature, and then you have to develop the section. Like for the honeycomb structure, it was a shell, so we'll select a shell, and aluminium material was applied, so we'll go with homogeneous, and then value the thickness you want that shell to be, so you can do that, and select the material as aluminium and then define. I've just already defined, so I'm not repeating the process. Like in this way you can define the honeycombs material as well as for the plate. Now coming to the assembly, like from this create instance you can select all of the parts and select the plate twice, like you have to attach it to the front and rear. So using these translate and rotation instance, you can assemble the model like I have assembled. I'll just give you an overview. Yes, now coming further to the step. In this step, we'll go to create dynamic explicit after just initial. We have to enter like uh, 0.1 or according to the need of the simulation, and rest will leave it as it is. So like I have already defined, so you have to click on OK. So and further in this field output request manager, we have to go to edit, and then in the failure and fracture, we have to consider all of these failures, and damage in initiation criteria has also been ticked. That's it for the field output. Further, we'll go to the interactions. First of all, we have to define the interaction properties. So we'll select the interaction manager properties. So in the first one, nothing is mentioned, like we can define the normal behavior. This would be for the just general contact explicit interaction. Like in the interaction first, you can observe general contact explicit at the initial step, and property is one that I just showed you. And in the second one is for the surface to surface contact, like the bullet surface, upper surface would conical surface would contact with the front surface of the plate, so friction would be incorporated. So I have considered the tangential behavior and define the friction coefficient as 0.18, and the interaction is surface to surface contact explicit, and the first surface was the plate's front side, and the second surface was the bullet's conical side. Like if you have to create this one, so I'll do just OK, create. For the general contact explicit, you will have to go take this one. Otherwise for surface, the second one comes from this, and then continue. So I have already defined. So now further you have to tie the front and rear plates to the honeycomb, like weld it properly so that it doesn't distort in a very you get the required results. So you have to select the tie constraint. Now continue. You have to select the master type, master surface. So in this one you have to select the plates lower end. I'll just show you the front plates lower end. You have to select the part this one and replace. Yes. So the back side of this front plate, surface, you have to select this one. Done. And you have to tell like which side. For that you can, like brown is this side and purple is this side, so you have to select purple. And for the next master slave surface, you have to select the each edge like this one on this whole honeycomb on the upper side, where you like imagine welding the plates. So in this way whole surface was selected and tied and the process was repeated at the back as well. So the structure was fully developed and welded. This sums up the interaction part. Now you have to define the load. For load, in the first you will see like there are 4 boundary conditions, but there are actually 2 boundary conditions. You can separately do it, or like combined way is also preferable. Like you have to, I'll just show you how to do it. Initial, symmetric, anti-symmetric. Take this and select this surface. Using the shift button, just select the other one too. Like this way, select all the edges, and going to done, you have to select the encasture property and fix these plates so they'll not move in the like when the impact is going on. And for the boundary condition 2, this means you have to select the displacement and rotation type boundary condition and pin the front reference point and deselect the U3 direction. So I'll just tell you why U3 is deselected, as the bullet will move in the Z direction to make an impact perpendicularly. So we need, like, in every direction bullet has to be fixed and only one direction it has to move. So that is the reason we have deselected the U3. Yes, like boundary conditions are now complete. We'll just go to, we have to define the velocity that we are providing to the bullet. So I'll just re-show you how to do it. You have to select like velocity and select a point. You have to select the reference point. Done. Translational only, you have to write 0, 0, and I have considered the low velocity impact. So velocity is 3 meters per second in the negative Z direction. So this is the value. Like yeah, this one. So load you have all defined now. Now coming to the mesh property, like you have to individually mesh every part. So first of all, for plate you can just go to this one and enter a value here and then apply. Reference mesh would be generated, and then you have to go this and OK to mesh, yes. Then a mesh like this would be developed. Now you have to select the elements type, as you have to change one, and select the whole plate. Done. By default the standard element library section is selected. You have to select the explicit, and the hourglass has to be enhanced. Element deletion, yes. Max degradation would be specified as this value 0.09999, and further there are no further changes. And for part 3, similar kind of mesh would be developed. Like for part 3 you can do it using the this seeds option. You have to select the edges one by one, like combine. I want this and this edges to be out of a specific length. So done. And you can specify the element size here or by number, like how many mesh lines you want over these edges. So by this you can define the by number of edges as well. And similarly you have to select the OK to mesh, and the element types you have to select as the explicit ones. Now coming to meshing the bullet, you have to go to mesh controls, and you have to select the quad dominated if anything else is selected or your mesh is failing over the bullet. And like similarly you can assign a explicit element type, and in this way a meshed assembly would be obtained. Now coming to the job, you have to create one, name it as impact. Now go to parallelization, use multiple processors. I've used 4 and done. You have to now either you can check the data, but to reduce the time you can just submit it, and meanwhile your every iterations that is going on will be shown in the monitor here, and if any errors or warnings are occurring, so they'll be informed in this section as well. And I have a completed file, so I'll just show you how it looks. So these were the iterations, and total CPU time was 1169 seconds. It is successfully completed, so no errors are shown. So if your file shows any error, just check it here and return back to the corresponding step. Now coming to the results, now the contours, as the refined mesh was generated, like not clearly the contours are looking. I'll just show you in a fast forward. So now for further results, you have to firstly I'll stop this. Yes, go to XY data, ODB history output. If you have to obtain all these things, I have to get the strain energy or the total energy. I'll just select the strain energy for whole model and plot. This kind of graph is obtained. Now if I want to develop this graph in the Excel, I'll just go to XY data here, and the temp, right click on it and edit. Now further I'll copy all this whole table, and if I'll plot it in Excel or any other software, it will result in the same graph. So just copy here and paste it where you want. Now if you want to develop the other results, like the resultant velocity, the residual velocity, and the deformation occurrence in the structure. So for that you have to select the ODB field output. This will give you at a certain node the results occurring, the deformation, whichever you want. So you have to go to this XY data, then ODB field output. Now your position has to be unique nodal. Now you have I first want the residual velocity, so I'll go and select the magnitude of the spatial velocity and go to elements and nodes section. I want the residual velocity of the reference point, so I'll go to node sets and then select the reference point. and then plot. It is plotting here, like taking some time, and yes, the velocity decreases as it impacts with the structure, and after a certain point, like time step around 0.055 or 57, it rebounds, and afterwards it just this one is a constant rebound velocity. And similarly, you can get the table by right clicking on this vmag xy data and edit, and you'll observe this tabular data of the same plot. Now if you want to observe the deformation occurrence in the structure, so we'll go to again ODB field output, continue. You have to deselect the spatial velocity and select the deformation occurrence in the Z direction. I want to measure that one. So I'll just instead of selecting the node sets, I'll just select edit selection, and I want to select the centermost point. So I'll go to this section and select parts, and front plate is this one, so replace. Now I'll just pick this point, edit selection again, as it would deselected. This node I have selected, and then plot. It will you can observe, yes. So this plot is obtained for the displacement occurring in the structure's front plate. Again, you can edit it and copy it in the Excel, time versus displacement graph. Similarly, if you want to find any result on a specific node, these all reaction forces, reaction moments, stresses, velocity, displacement, all of these things you can develop by acceleration using the ODB field output and selecting a particular node. Now I'll just okay. Now if you want to remove the mesh over the structure, over the whole model, you have to select the free edges. In free edges, your bullet will also not have any edge, which is preferred, like this kind of. Yes, now moreover, if you want to remove these title and the triad, you can go to viewport annotation and select all these things, whichever you don't want to show. Apply. I have by mistakenly deleted the hidden the legend as well, so legend is important. So yes, I hope this video helps you in simulating successfully and low velocity impact on Abaqus software. Thank you.